Good morning to everyone. Today I will come with the next new topic, work, power and energy. So we should go with this topic with full energy and bright concept. Come to the point. First one, we will discuss with the concept of work. What is work? In day-to-day life, if we will go in our surroundings and in our neighbor, we will find that everybody is saying that somebody is doing some type of work and somebody is doing the same concept is saying that he is not doing any type of work. Just like I am giving the example, if a mother of any son is saying that she is or he is sleeping to whole day or night, someone will say that he is doing work, but somebody will say that he is not doing any type of work. But reason is that if you will go with the English language concept with respect to the grammatical concept, you will find that sleeping, eating, each and everything are work. But with respect to the in the language of physics, we will come with it will state that there is no work. So what is work and what type of what are the factors on which work depends, it will stated by the physics language itself. In that one, I will discuss with the concept of work. Before going to that one, you will find a 2 point I have highlighted here. For doing any work in the language of physics, whenever a force is acting on the body, it displaces it. In real life, you will find that if you are taking any body, let it be. Suppose if I am taking any body A, and if I will apply any force, automatically it will get displaced. If I will apply the force of 5 Newton, let it be, it automatically will displace, suppose 5 meter. Then in the language of physics, we can say that it is a work, right? In that one, I have also written one more important point, that is point of application. What is point of application? In that one, if I will go, then you will find that point of application means, suppose if I am taking the example of this object and if I am applying a force on this portion, this body is going to be displaced from one point to another point. First point, it was here itself, means this portion especially called the point where you are applying the force, that is called the point of application, and this point is also going to be shift here itself, means there is a change in the position of this point with respect to on applying the force on itself, right? So this is called point of application. Next point, in this way we can define the work with respect to force and suppose force and the displacement, right? Overall, once you will go with this concept, you will find mathematically it has been stated in the form of W is equal to F dot D. So what is F? This is the force, this one is the displacement, already I have stated, and this force and displacement combined together in the dot form will give the idea of total magnitude of the work, right? So what is work? If you will go with this one, F dot D means F D cos theta, right? In the vector form, I will state in this way, F dot D, F D cos theta. So overall magnitude of the work you will calculate with respect to force and displacement like this one. Why we are using cos theta? We will go with this concept. Here I have applied a force of 5 Newton on body A. Now I am just going to change the concept. I am going to apply a force F at this position and the body is going to displace in this manner, right, and covering a distance of 10 meter, 70 meter, let it be. Now my question is that if this F force you have applied on this object, it is making a certain angle with respect to the horizontal portion, right? These forces, whether this force is applicable for displacing this object from this position to this position, no. This force component is applicable, that is if we will go with the concept, we will find that f cos theta, right? And this component, if you will find, this will becomes f sin theta. So when a body, this body is going to displace from this position to that position, who is responsible? F component, that is f cos theta component is responsible for displacing the body. That's why we combine together, again we can say that it will becomes f cos theta d, right? So overall magnitude of work depends upon the force, displacement and the angle between the force and displacement, because that angle is combined together to give the idea of the component of the displacement, otherwise it will give the idea of component of the force. Now in the vector we have already learned product of two vector gives a scalar, right? That's why work is said to be a scalar quantity. Next we will go with the concept, another one. Suppose we have done some work, right? If anybody will ask how much work has been done by you, what you will reply? You cannot reply in the language like that, I have done 2 liter work, 2 kg work, note, because physics always state that in each and every physical quantity have a certain unit, a specified unit for giving the proper idea of the measurement. So once you are going with the concept of work, you will find that its unit, and how its unit is coming, I will elaborate it. See, if I will go with the concept of SI unit of work is joule, and once you will go with the concept, you will find that F dot D is the value of work, and it is just showing just like a Newton meter, because unit of force is Newton and displacement is meter. Combined together give the idea of joule, right? In CGS form, if we will go with the concept to find the unit in CGS unit, then you will find that it is erg. How it can? Same, just like it is force unit is time, and in CGS it is centimeter, combined together to give the idea of erg, right? So basically the SI unit of work is joule and the CGS unit is erg. How it came? Already you have understood. Next point, if we have idea about the unit, then it maybe seems to be said that when you will go with the solving the numericals problem, you will find there is a unit conversion. Some quantity will be mentioned in CGS unit and some quantity will be in SI unit. So first you have to do what? You have to convert all this unit in a single system, right? Either you take CGS, either you take SI system. Prefer SI only. So you will find there is some unit conversion, that is I have converted in 1 joule into 10 erg, that is 10 is to power 7 erg, 1 EV 1.6 into 10 is to power 19 joule, and 1 kilowatt hour 3.6 into 10 is to power 6 joule. These all units you will find in each and every so many chapters upcoming. Now we go with the concept of dimension, and this is the important one. See, how we find the dimension of any physical quantity. So let it, suppose if I am going to find the dimension of work, first we have to understood the formula of work, right? FD, F dot D. Now listen, if we will find the force, dimension of force, and if we will find the dimension of displacement, combined together give the dimension of work. How it is? Then we know that force dimension, if you want to write, then you may write MA, mass into acceleration, and mass unit is kg, acceleration meter per second square, right? So you may write the dimension of force will becomes m, acceleration will becomes LT minus 2, right? And here displacement dimension is L, right? So combined together we give the dimension of work, that is m L2 T minus 2. In this way, we take the approach to find the dimension of any physical quantity. For that one, first you need to know the formula. After that, you go with the concept to find the dimension of each and every physical quantity in the formula itself and combine together to write it, give the dimension of that physical quantity. Okay. Next, if we have the clear idea of work, what is work, what is the unit of work, what is the dimension of work, then you will find that there is a term force and displacement, right? So first we will go with the concept of force. Actually, once you are doing any type of work, suppose if I am taking any object and if it is going to be displaced by the force acting on it, then I have just now I have elaborated that in the first case, if I will apply the force from this side, in another case I have taken the force in this side, right? In the both the scene, you will find that force is having the constant magnitude, but sometimes you will find that force is going to be varying, right? So with respect to both that one, I will go with the conclusion to get the value of work done with respect to constant force and with respect to variable force. So you will find here, once you will go with the concept of finding the work with respect to constant force, it will define the mechanical work, right? How much work you have been done by that. Next, it will vary work done in the various situation that whatever you are doing, it can be calculated. Next, work already we know W is Fs cos theta or Fd cos theta, that depends upon the what component you are preparing, right? So with respect to constant value, we need to get the calculation for work done once you are applying a constant force, right? With respect to constant force, you have to keep in mind first things, whether they are directly giving, means force and displacement, in force and displacement vectors angles are 0, whether they both are aligned together in the same direction. Otherwise, if it is at a certain angles, prefer to take their component. That's why it is in this figure it has been stated, and the same things it has been stated here. This is a block A. Suppose if I will take this, is it is going to be displaced from this position 1 to 2, and this force is going to apply at this moment. I will take the component of this force, and this component will be responsible for their displacement. In this way, we calculate the value of work done by the constant force. Next point, if we have understood the concept of work done by the constant force and work done by the variable force, with respect to that one, we have to analyze our theory in the form of numericals, right? So first thing you will find in the question, a very good question, a constant force, it is written 2i cap minus 4j cap plus 4k cap is applied to an object that is moving along a straight line, right, from the point that is given in the coordinate form, right? You may say x1, y1 and z1, same manner x2, y2, k2. Find the work done if the distance is measured in the meter and force is in the Newton. That's why I said, that time I have said that in case of unit, first you have to, if you are going with the question, solving the question, find the unit whether it is in the same system or not, right? Here they have mentioned both in the SI unit itself. Now we will go with the concept to solve it. See, this is body A. A force is going to be applied, this force F, that value they have taken. It is going to be displaced to this position, but they have not mentioned the exact displacement. And you people know very well that we have to calculate the work with respect to F dot d cos theta, right? There is no any angles, there is no any direct magnitude, or you can say constant magnitude of displacement. So what I have to do? First we have to find the value of this displacement. Let it be d. So how I will find? For finding the displacement, you will find that they have mentioned in the coordinate form. So use the concept in the mathematics, whatever you have applied, x2 minus x1, right, I cap, because I will have to take the same displacement in the vector form. The force is given in the vector form. That's why after that I will take the dot product, right? Next, by 2 minus y1 j cap and z2 minus z1 k cap. Apply here minus 2 minus 1, right? Minus 2 minus of minus 1. Don't we do any type of silly mistake in the exam, right? So here you will find it will becomes minus 2 plus 1 and value will becomes minus 1. So it will becomes minus 1 I cap, right? In the same manner, 4 minus 1 x2 by 2 minus y1, 4 minus 1, that will becomes 3 j cap. Next, minus 2 minus 3, minus 2 minus 3 means minus 5, it will becomes minus 5 k cap. Now you got the value of displacement in the vector form itself, and in the given question force value is also given 2I cap minus 4j cap and plus 4k cap. You need to find the value of work. How I will find the value of work? F dot d vector. So we will take the dot product of these two. What I will write? This will becomes 2I minus 4j plus 4k cap and minus I cap plus 3j cap minus 5k cap. If we will go with the dot product, I dot I 1, we have the clear idea about the vector dot product in the vector chapter itself. Then you will find that it will becomes minus 2 I dot I dot j or automatically 0, so no need to take that one. J dot j, it will becomes minus 12. K dot k, it will becomes minus 20. And in this manner you will find it will becomes minus 32 joule. So mention the unit very carefully. So in this way we have calculated the magnitude of work with respect to the given force, that is constant force, but it is in the vector form, and with respect to the displacement, right? Next, nature of work. Till now we have understood the clear idea about what is work, what is their unit, and what is the magnitude of work with respect to the constant forces when it is at a certain angle and when it is going to be at a constant value of force, right? Now we will discuss with the concept of nature of work. We will conclude nature of work includes three types: positive work, negative work and zero work. That's why in the starting itself I said somebody will prefer like that one, it is no any work has been done by you, but somebody will say no, it's a work. So that's why in the language of physics, when we will go with the concept of nature of work, we will find that positive work, negative work and zero work. We will discuss it one by one. Positive work. Come to this point. Positive work. What is positive work and what is the condition behind to fulfill the work is said to be positive. So first point you will find, everybody will know the magnitude of work is going to be calculated with respect to Fd cos theta. If I will take the value of theta less than 90 degree, I am coming to explaining one by one each and every term. Less than 90 degree, it means it's a acute angle, right? It's a acute angle. Now fill it. What will happen? This is a object, right? I am going to apply a force of 5 Newton. It is going to be displaced to this position 1 to position 2, right? This is the displacement. I have also mentioned the direction. Let me know in this question, force is in this direction and displacement is in same direction. So what is the angle between these two? Automatically you will say that 0 degree. Theta will becomes 0, right? So once the theta will becomes 0, what you will find? I said less than 90 degree, cos theta value is 1 and the value of work will becomes FD, right? In this way we calculate whatever the value of magnitude of work, that will becomes always positive. So first thing is that positive work depends upon the value of theta, that is also called cos theta. Next, positive work signifies the external forces already favors the motion of the body. That's why I have taken this example. In the same manner, force and displacement are in the same direction. That's why we can say that it favors the motion of the body itself, right? Second example, if we will go with the concept of positive work, a body falls freely under the action of gravity, right? See, this is a body falling freely to the ground, right? What type of force we will observe? We will observe this force is mg, right? Displacement, if suppose it is coming to the height h, means you will take displacement as h itself. Combining together the value, you will get both displacement and the force are in same direction, right? Again you fulfill the same condition and you will get the value of work. If you will go with the conclusion, you will find that free falling body under the action of gravity will becomes perform a positive work, right? So in this way we have the clear picture of positive work, when the work is said to be positive, when the work is said to be negative. I will come to the next slide. See, same manners. Suppose I have applied the force on this object with respect to an angle theta. This component is responsible for the displacement of this object from this point to this point. Here you will find the same, this component, that is f cos theta and the d displacement, both are in the same direction. That's why just now I have elaborated this one, no issue. Next, when the work is said to be negative, right, means you are performing a lot of works, after that output is nothing, in negative, means when it is said to be negative work, so many things are there. I will come with the example, I will also show the slide, no issue for that. If theta is greater than 90 degree, now listen, if theta is greater than 90 degree, means if you are going beyond this is 90 degree, if you are coming to this portion, this quadrant, mathematical approach you can take it, means it will becomes obtuse angle, right? And for obtuse angle, what you will find? The force, displacement and cos theta, right? Means if you will say, suppose I am taking the example, this is an object A, it is going to displace from this position 1 to position 2, when a force, but force is going to apply in this direction and displacement is taking in this direction, then what type of angle it is? More than 90 degree. In such situation you will find that if it is the direction of force and if it is the direction of displacement, the angle will becomes 180 and the value will becomes equal to FD cos theta, right? And this theta will gives the negative value. That's why we can say that work will be negative, right? In this way, we conclude that work is said to be in negative with respect to theta value, right? Same concept I have elaborated, that force opposes the motion of the body. Here you have find that body is going to be moving in this direction and the force is going to apply in the opposite direction. So both are opposing to each other. That's why this next point I have elaborated. Examples. Suppose you are braking the car, right? Once you apply the brake on the car, what you will find, apply the brake, force is in direction and displacement is in opposite direction. So what you have done, you can same things you will apply the concept and will say that it's a negative work, right? When the frictional forces is negative, when it is opposes the motion, then the work done by it will be called as negative. The concept behind it is also the same. Come to the next. This is the picture and you can just imagine the positive and negative work. Here I have preferred for this one. Just now I have elaborated theta should be greater than 90 degree, work will becomes negative. Now see this picture. In this picture you will find that it's a pole. Force is going to be applied by this person is in this direction, right? And this person is applying the force in this direction, already I mentioned. Now it seems to be found that this pole is going to displace in this direction. So you can prefer that if suppose it will F1 force is applied by this man and F2 force is applied by this man and displacement is along this side. So what you observe, with respect to this man, force and displacement, this is displacement, this is force. Angle between these two is what? 180 and value of theta will becomes negative. So this man will perform negative work, right? This man will perform negative work. Now if we will go with the concept of finding the work with respect to this man, he is also applying the force and displacement is along the direction of force. That's why we can say that this man is performing positive work because the angles with respect to this condition is 0 degree and cos 0 will becomes 1 and the value will becomes Ft itself, right? So here we can say that we have compared with respect to the negative and positive work with this diagram itself. So many examples are there also, no issue. Next, zero work, and this is very important one. Zero work. See, in day-to-day life we also say that yeah, this man has done a lot but output is zero, means overall work is done by him zero. See, W is Ft cos theta. It is coming in our mind itself. It's picture. This picture has been already set in the earlier lecture itself, right? Now, if value of F will becomes 0, automatically the work will becomes 0 with the mathematical approach. No need for that one. If value of displacement D is 0, automatically the work will becomes 0. You can say by a mathematical approach itself. In day-to-day life, I will also discuss. No issue. This one is the important. Just now you have understood the concept. When theta lie between 0 to 90, the work will becomes positive. When theta lie between 90 to 180, the work will becomes negative. What do you think about when it is on 90 degree? Means theta value will becomes 90 degree. This is the condition of zero work. Wow! If theta will becomes 0, cos theta value, so if theta will becomes 90 degree, cos 90 will becomes what? 0. We know every cos 90 value will becomes 0. That's why if we will go W F D cos theta, this value will becomes what? 0, and FD will becomes 0 itself. In this way we conclude for zero work this theta should be 90 degree. This is the first condition. Second condition, already we have elaborated F and D, that's the mathematical approach. Now if it is 0, then we can say that body is moving with the uniform velocity. Absolutely, right? If it is 0, means suppose if I am taking this one, if body is moving uniformly, velocity means just changing the time uniformly, right? Next force, net force of the particle is 0, right? This is also important one. Suppose if I am taking any object, applying the force 5 Newton from this side, and also applying the 5 Newton force from this side, see the direction, body will be in the equilibrium itself, means it will gain the net force value itself will becomes 0. From relative motion concept you can also get this concept, otherwise you can also gain it in the real life situation itself, right? I have mentioned the examples. Pushing the wall, once if I will apply the force on it, what will happen? I am just going to apply the force on it, but there is no displacement, so D value will become 0. Again the condition is going to be fulfilled by this, and work will becomes 0 itself. So for 0 work, these are the important conditions one should keep in the mind. I have taken the example. First one you will say, just now I have elaborated. In the second one you will find that D and F are perpendicular to each other, making an angle of 90 degree will becomes performing what? 0 work. Here is the best example, centripetal force and displacement, right? It is, at this point you will find that it is tangentially, this is the centripetal, this one, both are making an angle of 90 degree, right? And when it is going to be at 90 degree, again the work will becomes what? FD cos theta and cos theta, cos 90 will become 0, that's why it will becomes 0 itself. So these are the condition for 0 work. Next, that's the important one, and we have to understood the concept. Till now you have understood the nature, the definition, unit and the magnitude with respect to constant force. Now the second point is that dependency of frame of reference. This one is the main things, frame of reference, right? Whether the work depends upon the frame of reference or not, for that one you have to keep in your mind. I will elaborate each and every terms with respect to a fantastic examples, good example. See, I am just taking an example. Suppose that this is a lift. What is this? This is lift. In this lift, let it be a 2 kg block is placed here, right? 2 kg block, or you can say that there is a mass inside that one is. Next one, condition is that lift is accelerating upward. AC rating, I am rating in the short form, upward, right? Fill it. Lift is accelerating upward. A theft came into the existence, and you find that this, let it be gold, right? This 2 kg gold is inside the lift is accelerating upward, right? He observed, let it be, it is going upward with 5 meter per second square, right? From this position he observed that it is going to be accelerated, right? Now you think, on this 2 kg gold, if I am taking as a force, this is the normal one, right? There, at this point, for this theft, F and displacement both are in the same direction, right? Means displacement is going to be there. This is the case number 1. Case number 1. In this case, theft has observed, right, that force N is applied on it and it is going to be accelerated, means it is performing the displacement, right? Next, in the same case number 2, same condition. Now theft has reached inside the lift, right? Again lift is accelerating with 5 meter per second square, right? Now my question is that if police came and will see the same situation, again he will find the same condition. But what do you think about the condition behind that when theft is inside the lift and lift is accelerating, and this block, with respect to this block, if anybody will ask to theft whether it is in the motion, whether it is going to displace, he will reply no, because he is at the same reference point. He is the same point, and the same point both the forces are applied, that is N itself on both, but there is no displacement, means value will becomes 0 itself, right? So in both the cases you will find that force is independent of the frame of reference. There is no any change in the frame of reference with respect to force, but once the position of theft gets changed, in the first case it was outside the lift and in the second case it is inside the lift, right? Both the cases displacement, that is going to displacement on the frame of reference, it is going to change, right? That's why we can say that work done, now you know very well, work done Fd cos theta, right? F is independent, D is dependent, right? And D is dependent. So what you will observe, any one of them is dependent, means work will automatically becomes depend on the same frame. That's why we say that work depends upon the frame of reference itself. This is the elaboration with respect to the example. Come to the next point. If we have understood the concept of work and theoretical approach, we have taken the theoretical approach, then we should go with the numericals, because it will give the proper calculation of the knowledge, right? Next, work, a 10 kg block placed on a rough horizontal floor C. This rough horizontal floor, mass is 10 kg block, right, is being pulled by a constant force. It is going to be pulled by a constant force acting at an angle of 37 degree. Just now I have elaborated the concept. This is force acting at an angle of 37 degree, means what? This angle will becomes 37 degree, right? Means which one is responsible for just making the displacement of this block. Note this F cos theta, right? I will come to the point. The coefficient of kinetic friction between the block and floor, this is mu k, that value is given as 0.4, right? Find the total work due to the force F acting on the block if the displacement of block is 5 meter and this displacement is 5 meter. Think, all the data are given. These are the data given in the question. We have to calculate the value of work. So what you have to do? First, go through the FBD, that is free body diagram for work. What are the force is going to apply on the block itself? So you will find that this is F cos theta, another frictional force, right, and it is going to be displaced in this direction. No need for normal and mg because it will balance, no issue. So these two are the forces, right? And you people know very well work is Fd cos theta, right? So here you have understood the clear idea of the force component, that F cos theta is responsible for displacing this object from this position to this position. So first we will conclude the value of F cos theta. So in the competition, so many people have done always done mistake. For that one, I am just giving a basic idea. Suppose it is a triangle, don't forget it. If it is angle of 37 degree, automatically this angle will become 53 degree, right? So focus on 53, write this 3 at this same position and this 5 at this same position, either side, right? So in this triangle we will find that this 3 and 5, it automatically by Pythagoras theorem it will become 4, right? So now it's very easy for you people, don't be confused in the exam, you will get the clear idea for cos 37 degree or sin 37 degree, whatever they will ask. So here you will find F cos theta value, F cos 37 degree will becomes, F value is how much? It is given in the question 100 cos 37 BH into 4 upon 5. It will becomes 80 Newton, right? So first things you have calculated. Secondly, FR, for that one, if you will go with the calculation of FR, you will find that it will becomes mu n. Mu value is given, need to calculate the value of n, and n value will becomes equal to mg. So this is n and it will becomes mg. Mass is given, g value no, so this value will becomes 10 into 10 will becomes 100 Newton, right? From here we can calculate the FR value, 100, mu value is 0.4 will becomes 40 Newton. Now my question is that you have the clear picture of a applied force on the object. What are these? You can write. FR value is 40 Newton, right? F cos theta value will becomes 80 Newton. Now let's just go with the concept. This side a force of 40 Newton is going to be applied and for that object this side is force of 80 Newton is going to applied, and body is moving in this direction, means this force is dominating on frictional force, right? So F net value you can calculate from here, that will be applicable for this block, that is F net will becomes equal to 80 minus 40 Newton, and it will becomes 40 Newton, right? So you have calculated the F net value. Now thing is that once you have calculated F net, you can calculate the work, so easy. So F net value is 40 Newton, D value is how much it is 5, it will becomes 200 joule, work will be done. Got it? In the same manner, concept behind is that this force, frictional force, this side F cos theta, both are in opposite in nature, so take the difference of that one, you will get the F net value, and for that one you just go with the multiplication of D, because F cos theta component and D is in the same direction, for that one only theta becomes J, that is value will becomes 1, right? So in this manner we can calculate the value for work done with respect to the constant forces applied at a certain angles on an object, right? So next, okay, let it be. I will discuss with this all rest concept in the next lecture, and in that one there is also a good numerical approach with respect to the variable forces, and in that one I will conclude the quantity of, that is magnitude of the work, that will be with respect to the variable forces. How we will calculate, later this will be elaborated with respect to the next session. And thing is that some more important numericals were there with respect to the pulley and with respect to inclined plane. These are the important ones. Actually, these are question I have taken from the content itself, and it will very helpful for you people. These are the repeated question also, that will give the proper idea. Thing is that how you are thinking, the method of thinking, in which way you are going to take the right approach for the question. Thank you.